Okay, so we're going to try a new experiment here. Let's get these masses. Got it?
Yep.
And that's there. That's that thing. Okay. And then I do want to point out some distances here. Let's slide this on. And so before we get too far ahead of ourselves, I'll show you what I'm going to do. Okay, so each time I'm going to go ahead and set this up here like this. And so right now, why don't you record? Can you see it okay? I'm going to set the end of the black rod right at the end of the meter stick, which is almost exactly 0. Notice where the screw hole is there. Okay, so you can note the screw's position, and also you can note where the brass piece is. So far so good?
Yeah.
Okay, and then let me mount this on here. So now they have the distance. And let me get rid of all this old data. Just a second. So we just did this and then we got confused when we tried to read the data. So what I'm going to do is each time we'll measure the distance. This is set up right here. And just to show you, so that when I pull this all the way up and it touches that, it's not perfect, but it's, well, if I can actually hold this thing, it's, see that? Hopefully you can see that's about level.
Mm-hmm.
So that means we're releasing it from a right angle, okay? And hopefully this will work. So I'm going to run it and I'll pick out the max velocity that I can see here, and that'll be what we get. So
You want to measure this one, or I guess we just did technically?
yeah, we just measured it, right?
Yeah.
So here we go. Okay. And now, so I don't get lost, this is what happened before. I'm going to go in here. That looks like the max. Got it?
Hold on. I think so, yeah.
Okay, so I'm reading time on this axis, and then I'm reading angular velocity, radians per second on this axis. So that number was negative 11.26, if it didn't focus. Okay, so now I'm going to try and move this. I'm going to get rid of this data so I don't get confused. And we'll do this again. We'll move this just a little bit. This is one of my favorite experiments, to be honest. I know it seems a little crazy, but it's actually pretty interesting to me. Got it?
Yep.
So as this goes, think to yourself, obviously you're going to see the data any second now, but think to yourself, this is the one fun part, which position is going to make this go the fastest? Is it going to be close to this end, or close to that end, or what? Or is it in the middle? Let's find out. So take your guess, all right? Why not take a guess, and then it'll be more fun. So we measured this, right? Oh man, I'm tired. It's going to be a long video, but let's get this over with. Here we go. Next one, right?
Mm-hmm.
Oh, shoot. Did you see that?
No.
The brass.
Oh.
I looked at just the last second. This
Yeah.
one's not level.
We could just skip that one and go to the next
skip
one.
that one. And sorry. We'll come back to that one, okay? So right at the end, we'll do that one again. Sorry, that one's no good, right? So, I'm glad I saw that. Joys of experiment. So we got to measure it again, right?
Yep.
Because that's no longer a good measurement. Doing okay?
Yeah.
Good. So when we come back at the end, we'll get this one and we'll just pull that out and try and get it as level as we can. Okay, so now, gee, I wonder where the maximum is. It's probably right about there. Anyway, so let's find out. We'll see. Now it depends on the rod. I haven't done this particular rod. Okay. I could be wrong. It might not be there. But much better system than the last video. You could definitely see how much it loses after it swings back, right?
Mm-hmm.
And it's not too bad. Okay. It's up right. Whoops. Come on. Oh my gosh, this thing's messing with me now. Got it? Negative 10.95. We're going downwards.
All right.
Going downwards. Hold on, this thing's doing some weird stuff. It's got this slope calculation going there. Sorry about that. I don't know how to get rid of that. There we go. Negative 10.52. Isn't that interesting?
Yeah.
Is that what you expected?
Oh, yeah.
Yeah, nice.
No, it's not. It's not.
It's so counterintuitive, right?
Right. All right.
Going down.
All right.
So you can see why that one data point was so critical.
Right.
Actually do this in the workbook too.
All right.
This is going to be a long video, isn't it? Oh, this is coming loose. There you go. Definitely going downwards. Okay. Get this one right. Good. This and this. Cool.
I think so, yeah.
Now, I guess we might as well get all the way out, just because it's the right thing to do. So you probably don't need to measure this one, but just in case. Should be 38 all the way to the end, I think.
Yep.
Okay. And remember, we got to get that one data point, okay?
Yep.
So, there we go. Not much change. Okay, and so then, I know where it was. It was right about there, right?
Mm-hmm.
Let's just go right in, right there. So now we got to raise this up. That should be about level. Let's check. Not quite, huh? Actually, that's pretty good, right?
Yeah, it looks good enough.
Okay, so that's, it's not perfect, but it's pretty close. Tighten this up. And then, now let's get your distance. Last one. Okay, here we go. Clearly bigger than what we were just looking at. Let's see. Come on. Ooh. It's pretty big. I don't know if it's the biggest, but it's pretty close. So we definitely saw as you move outwards, the velocity seems to drop. So somewhere in this middle region here was where it was a maximum, and hopefully when you look at the data you can see that. Oh, and just for kicks, let's look up here. We see that it's 9.29 here versus a 9.95 there, so it definitely loses something between the oscillations. You can even see it there. Each time it swings, it's going to slow down a little bit from friction, but hopefully that's negligible.
All right.